Rainwater harvesting in urban settings. In India, rainwater harvesting has been in practice for more than 4,000 years. Ancient Indian civilizations developed various methods for rainwater harvesting. These included the construction of step wells, tanks, reservoirs designed to capture and store rainwater during the monsoon season. Historically, harvested rainwater was used for drinking purposes. The practice ensured a clean water supply, particularly in areas where other sources of water were less. Rainwater harvesting systems provided water for agriculture, helping to grow crops and improve agricultural productivity. Water collected from rain was also used to provide drinking water for livestock, supporting pastoral livelihoods. Rainwater is generally of high quality and free from many of the contaminants found in surface water sources. It is often clean and does not require extensive treatment before consumption. Rainwater typically has a low level of dissolved minerals, which can be beneficial for various uses and reduces the need for treatment. Surface runoff harvesting involves capturing and storing rainwater that flows over land surfaces during and after precipitation events. This method is particularly suitable for urban areas where impervious surfaces like roads and buildings increases the amount of runoff. Runoff from rainfall is redirected through channels, pipes, or gutters from impervious surfaces like roofs, pavements, and roads. This redirection helps to gather the runoff into designated collection areas. Surface runoff is collected in specially built ponds, tanks, or reservoirs. These can be constructed above ground or below ground, depending on space and design. Large reservoirs are designed to store substantial volumes of water, allowing it to be available for longer periods. These reservoirs can be built on site or within a broader urban water management system. Now, what are the benefits of this harvesting? Stored runoff can be treated and used as a clean, potable water. In urban areas where traditional water sources may be limited or overburdened, this provides a reliable supply of drinking water. The harvested water can also be used for various domestic purposes such as cleaning, gardening, and toilet flushing. So this image illustrates the concept of surface runoff rainwater harvesting. So first you can see rainfall. It is represented by the blue dashed lines. Rainfall is the source of water in this process. Then is the land surface. This is the ground where the rain falls. The land surface can vary in its ability to absorb water depending on factors like soil type and saturation level. Saturated surface layer, the upper layer of soil which has become saturated with water. Once this layer is fully saturated, additional water will either run off or infiltrate deeper. Water table, the level below which the ground is saturated with water. The water table separates the saturated subsurface zone from the unsaturated zone above. Infiltration, excess overland flow. When the rainfall rate exceeds the infiltration capacity of the soil, water flows over the land surface. This excess water is collected in the harvesting system. Saturated subsurface zone, the area beneath the land surface where all the pore spaces in the soil are filled with water. This zone includes the water table. Then stream, the water body where collected runoff is directed. In rainwater harvesting, the stream could represent a storage area such as pond, reservoir, or tank. Then you can see arrows for infiltration and flow. So black arrows indicate the movement of water. The downward arrows shows the infiltration where water moves from surface into the soil, and the horizontal arrows, they show the overland flow of water, which is the surface runoff moving towards the stream. So altogether this image explains how rainwater that cannot be absorbed by the saturated land surface becomes surface runoff and this runoff can be collected and directed towards streams or storage facilities. Rooftop rainwater harvesting involves collecting rainwater that falls on the rooftops and redirecting it into storage containers for later use. This method is popular in urban areas due to its simplicity and effectiveness, especially in locations with ample roof space. Rainwater is collected from the surface of the roof, which acts as a catchment area. The water is initially collected as it falls onto the roof. The collected water is stored in containers placed beneath the roof level. These containers can be tanks, barrels, made from various materials such as plastic, metal, or concrete. Containers are usually constructed or installed to be durable and to prevent contamination. They can vary in size depending on the amount of rainwater to be stored and the intended use. Water is redirected from the roof to the storage container through pipes. These pipes can be made from materials such as wood, bamboo, or PVC. The choice of material depends on factors like cost, durability, and local availability. The system is relatively simple to install and it can be implemented in various settings, including homes, schools, colleges, and other institutional buildings with adequate roof space. So in this system, the roof of a house or building serves as the surface or catchment that collects rainwater. When it rains, water falls onto the roof and is gathered by the system designed to channel it away from the roof surface. Rainwater collected from the roof can be directed through gutters and downspouts into storage containers such as tanks or barrels. Instead of storing the water, it can be diverted to an artificial recharge system also. This system helps replenish groundwater by allowing the collected rainwater to infiltrate into the ground. This can be done using various methods such as recharge pits, wells, trenches. The system is relatively inexpensive to set up. The primary cost involves the installation of gutters, downpipes, storage containers, or recharge systems. Since it uses existing roof structures, there is minimal additional expense. By collecting and storing rainwater, you can have a reserve of water available for various uses, reducing dependency on external water sources. Diverting rainwater to an artificial recharge system helps to increase the groundwater levels. This is especially valuable in areas where groundwater depletion is a concern. So these are the various components of rooftop rainwater harvesting: catchment, gutters, downtake pipes, filters and first flush devices, storage tanks, delivery systems, recharge structures. We will study this in detail. So first component is catchment. The area or surface which receives the rainfall is known as catchment area for rainwater harvesting. It may be rooftop, courtyard, open ground, etc. In the simplest method, rainwater is collected in vessels at the edge of roof or open ground. Then rainwater collected from the roof is directed through gutters, which are installed along the edges of the roof, and downspouts, which are vertical pipes that channel water from the gutters to the storage containers. Sometimes the collected water is also passed through settling tanks for suspension of settleable particles before the collection in storage tank for domestic use. Then gutters and downtake pipes. Gutters are installed along the edges of the roof to collect and channel rainwater that falls onto the roof surface. They direct the collected water towards the downtake pipes. Gutters should be sloped to ensure that water flows efficiently towards the downpipes. They must be adequately sized to handle the volume of rainwater expected during heavy rainfall events. Downtake pipes. These are vertical pipes that carry rainwater from the gutters down to the storage tanks or artificial recharge systems. They ensure that water is efficiently transported from roof to the collection or storage points. Then materials which are used for gutters include galvanized iron sheet. Galvanized iron is commonly used for gutters due to its durability and resistance to rust. It is coated with a layer of zinc to protect against corrosion. Then wooden gutters are less common but can be used, particularly in traditional or aesthetic applications. They require regular maintenance to prevent deterioration. Bamboo, it is an eco-friendly option that can be used for gutters. It is suitable for regions where bamboo is readily available but may require treatment to enhance its durability. Then reinforced cement concrete RCC. These gutters are highly durable and can be molded into various shapes and sizes. They are often used in larger or more permanent installations. Then materials for downtake pipes, galvanized mild steel. This material is often used for downtake pipes due to its strength and resistance to corrosion. It is coated with zinc to enhance its durability. Cast iron pipes are known for their robustness and longevity. They are suitable for systems that need to withstand heavy usage or adverse weather conditions. Then high density polyethylene. It is a type of plastic known for its flexibility, durability, and resistance to impact and corrosion. It is lightweight and it is easy to install, making it a popular choice for downtake pipes. Filters and first flush devices. Now these devices are used to remove physical impurities from rainwater, such as grit, leaves, dirt. These impurities can come from the roof, gutters, and downpipes. So as rainwater flows through the filter, it passes through various layers of filter media that captures and remove the contaminants. So which types of filter media are used? Like gravel. Coarse gravel is used to filter out larger debris and provides a first layer of filtration. Sand is used for finer filtration. It captures smaller particles and improves the clarity of the water. Then coconut and palm materials are the natural materials that can be used in filters due to their fibrous nature, which helps in trapping impurities and provides a sustainable option. Filters help to prevent contaminants from entering the storage tank, which could otherwise degrade the quality of the water. Then first flush devices are designed to divert the initial flow of rainwater away from the storage tank. This is crucial because the first rain of a storm often washes off accumulated debris, dust, and pollutants from the roof and gutters. This device temporarily holds back the initial flow of rainwater, allowing it to flush out contaminants before directing cleaner water into the storage tank. Storage tanks. These tanks might be either underground, above ground, or partly underground tanks. So first is above ground tanks. These tanks are installed on the surface, typically elevated or placed on a stand to facilitate gravity fed water distribution. Then underground tanks. These are installed below ground level. They are less visible and can be integrated into the landscape without occupying surface space. Then partly underground tanks. These tanks are partially buried with a portion exposed above ground. They combine aspects of both above ground and the underground tanks. Then construction materials used. Reinforced cement concrete. It is a strong and durable material that can withstand external pressures and environmental conditions. It is commonly used for both above ground and underground tanks. It offers high structural integrity and resistance to leaks and cracks. Masonry. Masonry tanks are built using bricks or stones, often with a cement or mortar binding. They are typically used for underground storage. It provides a strong and durable construction. However, this may require additional waterproofing measures. Then size of the tank should be sufficient to meet the daily water needs of the household or facility. This includes considering water for drinking, irrigation, or other uses. Then the tank should have enough capacity to store water that can last through periods of low rainfall or drought. The size of the tank should be proportional to the catchment area, that is roof size, to ensure sufficient water collection and storage. The expected volume of rainfall in the area should be considered to determine the appropriate tank size. This helps in estimating how much water can be collected and stored. Then tanks should be always covered to prevent contamination from debris, animals, insects. A well-fitted cover helps maintain the cleanliness and quality of the stored water. Underground tanks should be lined with waterproofing materials to prevent water seepage and maintain structural integrity. Common materials include bituminous coatings or cementitious waterproofing compounds. Then for underground tanks, installing a hand pump can facilitate easy withdrawal of water. It is especially useful in areas without reliable electric power for electric pumps. Delivery systems. There should be efficient piping systems which can deliver the stored water for the end use. Rainwater, if not treated, should be used cautiously for purposes like irrigation or cleaning, but should be avoided for consumption and cooking. For potable use, conventional water treatment methods, for example filtration, disinfection, are necessary. Leaking pipes can waste water and lead to reduced pressure in the system. Regular inspections help identify and fix leaks promptly. Rusted pipes can contaminate the water supply and reduce system efficiency. Use materials resistant to rust such as PVC or HDPE and replace rusted components as needed. Regular inspections of the piping system, including joints, valves, fittings, are necessary to detect and address issues like leaks, clogs, or damage. Periodic cleaning of pipes and components help prevent blockages and ensure smooth water flow. Before delivering water to consumption points, it should be treated to remove contaminants. This may include filtration, sedimentation, and disinfection processes. Recharge structures. These structures are designed to facilitate the infiltration of harvested rainwater into the ground, thereby replenishing groundwater aquifers. So there are various types of recharge structures like dug wells. Dug wells are manually excavated wells designed to capture and store rainwater. They can be lined with masonry or concrete to prevent contamination and collapse. Rainwater collected from the surface is directed into the dug well, where it percolates through the soil and replenishes the groundwater aquifer. Recharge trenches. These are shallow, long, and narrow excavations filled with gravel or other permeable materials. They are typically constructed along the contour of the land to intercept and infiltrate rainwater runoff. Rainwater flows into the trench where it is filtered through the gravel and gradually infiltrates into the ground to recharge the aquifer. Recharge pits are small deep holes or pits filled with coarse material such as gravel or stone. They are designed to capture and infiltrate rainwater into the groundwater system. Rainwater is directed into the pit where it infiltrates through the gravel or stone and replenishes the groundwater. Before constructing recharge structures, assess the potential risk of contamination from nearby sources, such as septic systems, industrial activities, or agricultural runoff. Implement design changes to mitigate contamination risk, such as using impermeable liners, creating buffer zones, and ensuring proper filtration. The effectiveness of recharge structures depends on the permeability of the soil. Soils with high permeability allow for better infiltration, while less permeable soils may require modifications to improve water infiltration. Choose locations with suitable soil and topographic conditions to maximize recharge efficiency. You should avoid areas which are prone to flooding or where the groundwater table is already high.